All right, so our next shape that we're going to talk about is a rhombus. A rhombus is a parallelogram as well, and it's special and different from a parallelogram because it has four congruent sides. Four congruent sides. So let me see if I can get one shaped out here. There we go. That looks good. So here is my rhombus. It has all four properties that a parallelogram does. So let's just review some of those. One is that opposite angles are congruent. So I have congruent angles, but they are opposite of each other. They are also have opposite sides are parallel. So our little parallel marks. And opposite sides are also congruent, but all four sides here are congruent. So I have one dash that's going to go on each side. So kind of like a square, guys, that all four sides are congruent. We also know that just like a parallelogram, the diagonals bisect each other. Diagonal 1. Diagonal 2. And we'll throw some marks of congruency on there. So these two are congruent and these two are congruent. Now, I do not know that my diagonals are congruent to each other. So I can't say that all four pieces of my diagonals are congruent. That's not something I'm allowed to say. So that covers all of my, computer, stop. That covers all of my bases for our four parallelogram properties. So then I'm going to add in the two additional rhombus properties. Yes, I know, stop. Pop-ups, go away. Your two new additional pieces are, one, that the diagonals are perpendicular. Your diagonals are perpendicular, so you have right angles inside here. So now you have four right triangles to handle. As I said earlier, parallelograms are full, or quadrilaterals really, are full of triangles. So we're going to use these triangles to our benefit to solve for missing pieces. The other thing that they do, and it's so great, is that they bisect opposite angles. So they cut the other angles in half. So if I were to name this, I'm going to go ahead and name it A, B, C, and D. So the diagonal AC is bisecting angle A and angle C. It's cutting them in half perfectly. So they're congruent on either side. And diagonal BD is bisecting angle B and angle D, cutting those in half. So you have all sorts of great angles of congruency and right angles. We have some great stuff that we can work with to solve for missing pieces. So let's look at some examples with that. So the first one, if the diagonals for A, B, C, D meet at point F. So I need to add some diagonals here. It's telling me to draw them. That was kind of curved. It's hard drawing straight lines, guys. Just do the best you can. So if the diagonals meet at point F, so this is now point F, and angle CBF, CBF. I'm going to highlight that so it sticks out. Use its bright color. CBF, that's this angle in here, is 22 degrees. What is angle DCF? So this is CBF is 22 degrees. So we can make DCF blue, DCF. The screen just wants to run away from me. DCF. So this is DCF. So this angle right here is what I'm trying to find. Oh boy. Well, DCF. Oh, the C is in the middle. Hello, paying attention. The C is over here. That's the angle I'm looking for. That makes a little more sense. So in order to find this whale, we're going to need to find a few things. First thing we need to remember is that we have right angles in the middle. So I have a right angle right here. So now I have a right triangle. I'm going to sketch it out over to the side here with B, C, and F, with B being 22 degrees. And then I have, just going to sketch it kind of detached. It makes it a little easier to look at. This is not as great of a picture as I was thinking it was going to be. There we go. That looks more realistic. That is also a right angle, and I am trying to find this angle right in here. Okay, so I have right triangles. So I can solve for angle BCF right in here. So I'm going to take 90 minus 22. And I'll get a little spazzy there. 68. So angle C on this side is 68. But looking back at our drawing at the top, our diagram of a rhombus, FC is bisecting this angle. So these two are actually congruent to each other. So I can say BCF is congruent to DCF. So X is 68 degrees as well. So the measure of angle DCF is 68. Okay. Don't forget all those marks of congruency. Let's look at examples 9 and 10. So example 9 says find Y. Well, alrighty then, let's do that. So Y is used in two different angles. It's used in angle TSW up here, but it's also used in SWT. But one of these angles we already know the measure of because it's a part of the diagonal, and where the diagonals meet, they are perpendicular. So this angle right here is 90 degrees. So to solve for Y, all I have to do is take 2Y plus 10 and set it equal to 90 degrees, or 90. And solve for Y. Subtract 10 out. 2Y is equal to 80. Therefore, Y is equal to 40. I like to go ahead and plug that in. So this angle up here is 42 degrees, and which is what it's asking us for. We take that 40 plus 2 is the measure of angle WST, which is 42 degrees. It's not a super complicated problem there. Make sure you remember the diagonals where they cross in a rhombus makes a right angle. So you can always, always, always set whatever that is equal to 90 degrees. All right, let's look at, this looks like a complicated example. It's got multiple steps, so I'm going to reset the video and do this one separately.